My name is Jon Bruner. I'm the co-chair of O'Reilly's new conference called Solid, which is about software and hardware and the way that they've come together and intersected and extend each other. Our thesis in putting the conference together is that a lot of people have moved from software into hardware as a way to kind of extend what they've done in software into the physical world. So the showing tonight supports that. So many of you are from startups. So many of you have sort of blended software and hardware. I think it's fascinating. So to introduce our panelists, the first is Dan Saffer, who's the creative director at Smart Design.
Thank you.
Next we have Rachel Kalmar, who's the data scientist at Misfit Wearables. And Mike Kuniavsky, who's the principal scientist at PARC. A principal scientist at PARC. Thanks, everyone. I'd love to hear from each of you. I'll just go down the line. And what do you do? Dan, what do you do?
So I'm a creative director at Smart Design, and Smart Design has been traditionally a hardware company. We're most famous for all of the OXO kitchenware that's in all of your kitchens, I'm sure. And over the last couple of years, we've definitely started to move more into connected devices, and particularly connected kitchenware and wearables. So that's kind of what I do and where I'm at.
Awesome. Rachel, what do you do?
What do I do? So my name is Rachel. My background is actually in neuroscience, and so I've spent most of my career looking at noisy signals and trying to understand how they relate to behavior. And what I'm doing now is oddly similar in that I take in many streams of noisy signals and try to understand how they relate to behavior. So at Misfit, I'm a data scientist, so work on everything from trying to figure out what kind of data do we need to collect to build our algorithms, how well are our algorithms doing, how do we make this data actually useful. We don't think that step count itself is necessarily something that people care about. How do we take this to the next level? And one thing that personally I have spent the last year or so doing is trying to figure out how do we set up an ecosystem such that we can get data from all of these different devices. I'm wearing over 30 different devices, as I do every day, but I can't get the data. You can ask me about that later.
Mike, tell us about what you do.
I was going to say, what I really do is project management and business development. But what my group at PARC's Innovation Services at PARC, which many of you know from its era at Xerox PARC, it is now its own entity. So what we do is we help our commercial clients integrate a bunch of PARC's different technologies. And PARC is interesting as a research lab, as a commercial research lab, in that we do the full stack of technologies, essentially all the way from like bare silicon all the way up to cloud-based services and kind of everything in between. We do networking technology, we do kind of data analytics, we do user experience design, and we do hardware development, and we actually do kind of novel, like wholly novel silicon device development. So the whole stack.
Excellent. So none of the three of you is like a hardcore electrical engineer in a straightforward sort of went to MIT and got an EE degree kind of way. But now all of you are pretty prominent in hardware. So how did you make the transition? How did you get from backgrounds as designers, as PhD neuroscientists, into sort of dealing with hardware? What inspired the shift?
I'll start. So I got an undergrad in computer science back in the dark ages of the 80s, when you actually had to know something about hardware. And I got very excited about it, but then I kind of dropped it and became a designer for 15 years. And primarily software UI, UX design. And then after that much time, I just got really sick of just pushing pixels around and having them disappear when the venture failed a year later. And I really wanted to get back to kind of the really kind of the essence of ubiquitous computing. And this was like 10 years ago, and I went and started soldering again. So.
I think if I can extend our polling for a little bit more, how many of you are like in the stage where you're experimenting with soldering, or you're dipping your toe into electronics? You're all sort of like embarrassed to raise your hands a little bit, but I think there's something really honorable in like having an oscilloscope on your desk and like staring at it fearfully for a little bit before you really get into it.
Although I think there is a fetishization of that level of stuff. Really, you don't want to debug with an oscilloscope ever. Not if you can help it.
But it's so pretty. But it's so pretty.
I just try to make patterns.
It can be
for the
fun.
first 8 hours.
Debugging code isn't necessarily any better.
No, it's true.
So I actually started out as electrical engineering as an undergrad and wanted to work on neural prosthetics. And I was an undergrad at UCSD, and there weren't any labs at UCSD working on neural prosthetics, but there was one line at the bottom of this website about signal processing in the retina that it had applications for prosthetics. So very naively, as an undergrad, I said, okay, well, I'm going to go work in this retina lab. I'll figure out how the eye works, and then I'll just build electronics that plug into the optic nerve. It can't be that hard. It's just electricity, right? And that was the beginning of a 12-year detour into neuroscience. Also, as an electrical engineering undergrad, they weren't explain how transistors worked. And they said, oh, you'd have to go to physics to do that. So I ended up graduating as a physics major instead. But I was still interested in kind of the using whatever tools necessary to learn about human behavior and sensory perception and be able to understand that and manipulate that. I think it's been a kind of a zigzag course, but I'm still interested in the same things.
Excellent. And people who are watching you on the screen have probably noticed that you're an expert on measurement and are testing out a lot of different ways of measuring things.
Mm-hmm. I still have more space.
There's always room for another wearable, right?
Mm-hmm.
Right.
And my background, so like Mike, I came more out of the traditional kind of software web application, web space. But sometime around 2006, 2007, I started to get really interested in designing for touchscreens and gestural interfaces, which then started to involve a lot more ergonomics, and the body mattered a lot more. There's a lot of things that you could do in space that you can't do on just a screen with a mouse. So that was the hook to get me really into it. And afterwards, I said, oh, well, I'm going to start my own studio to do hardware and software, and I did that for a couple years before joining Smart Design because
and it was awesome.
They had all the and they had all the hardware. So
right, and it tells about sort of what you found in the way of sort of differences in designing for the physical world as you started to approach it. I mean, is there more nuance, more unexpected collisions between things?
It's a lot trickier. I mean, there are a lot of standard patterns that work really well for web and software now that are really well known. There's a lot that's still being discovered about the hardware-software collision that is we're still trying. I mean, look at the number of these things here on Rachel's arm. I mean, they're all different and do things very differently, and we're still
also show that I have a bunch on my phone as well.
Yeah. If
let me show.
And that's not
exactly. That's not. Yeah. So we don't have to go there. So there is just a lot of new things, like the combination of what should this button do, what should this dial do, how does it interact with the screen? Is there a screen? Where does the functionality move between software and hardware? Should it be a button? Should it be a thing on the screen? There's just so many different kinds of choices, and some of those choices get locked in a lot earlier and harder when it comes to hardware, where the atoms part is is so much harder than the bits part in terms of being able to change things once it's locked in. That's been the biggest difference.
Yeah, the cycle time is so much longer. You know, the cycle time for experimenting and learning from your mistakes.
The mistakes are so much painful.
Yeah, I mean, although to be honest, I think that if we use the web as an imperfect analogy, like we're still in the gopher territory, right? We still have not gotten to the point where we can plug pieces together and look at how pieces are plugged together to understand how to plug them together better.
Sorry.
Yeah, go ahead.
How crucial do you think it is to understand hardware? How deep of an understanding of hardware do you have to have in order to execute kind of hardware-software hybrids really well? Like Rachel and I were having an exchange on Twitter the other day about modules and the ability to sort of take modules and put them together. Will we ever get to a point where you can design really great hardware by just taking modules and putting them together and writing software on top?
I think it all comes down to what's your goal or what are the questions you're trying to answer. There are amazing things you can do with Arduinos, but you're not necessarily going to be able to take an Arduino and turn it into a consumer-facing product because you need to optimize things like battery life. You need to optimize for efficiency. And there's always going to be a trade-off between flexibility and optimization.
Mm-hmm. Yeah, I mean, my experience is, so I have with my business partner, Todd, I've had a hardware startup for about 7 years at this point. And I'll answer the first part of your question by saying I actually got to skip a lot of the hard parts by getting a business partner who is a Caltech trained EE. And so he can just solve all the problems. But that still doesn't mean that we actually that it actually approaches software, and I think although hardware is becoming more object oriented, and you're getting more and more capacity in larger like modules and both systems on a chip are all developing kind of new greater capacity. There's still a big jump between getting it to work on a breadboard and getting it to work as a product. Because once you try to make that jump, it's not like the thing about that software people, I think, don't necessarily get, that I'd certainly forgotten about hardware, is that you get, like in software, if you get it to work once, well, it works. Like, I can compile this on another machine and it'll work again. I compile this on another machine, I'll run it again and it will work again.
Unless you're talking about browsers.
Well, okay, yes. Right. But, you know, in theory, there's just a lot more consistency and portability, whereas with hardware, you don't get any of that. Like, you have this thing on a breadboard, it's not done. Like, it just, it's the first tiny little bit of an idea that it could possibly work as a product.
I think it's that that kind of complexity that people run into when they realize that they have to understand the sort of underlying concepts in the electrical and mechanical aspects of what they're doing, right? And really blend insight from that and from the software. And Rachel's wearing a really cool pedometer that predates electricity, as like an illustration of these devices that blend elegant hardware with elegant software. At one end of the spectrum is one of them that is strictly hardware.
Right.
Mm-hmm.
Yeah.
Yes.
Yeah.
I'll just keep talking, but I want to keep talking.
I mean, I would also point out that as a hardware product, you have to decide at some point problems. Whether you are a developer device first or a consumer device first. Yeah. Because you're going to build a very different product if you're building a product for developers versus for consumers. If you're building a product for consumers, then your first priority is to make a great user experience, and you're just going to have different constraints. And so people come up to me all the time and say, oh, can we get raw accelerometer data off the Misfit Shine or off of any of these other devices? And the answer is no. None of these devices store raw accelerometer data because you run into a space constraint. You would run out of memory much more quickly and have to sync your device more often. And so things like that are trade-offs that you don't necessarily think about unless you're trying to either build a consumer product or a developer product.
Yeah, and I think that there's, so Thingam, my little company, has launched both products for developers. Essentially, we've launched components and consumer-facing products on Kickstarter. And the expectation is way different. Like, well, also, the developer community, especially on Kickstarter or wherever, you're guaranteed to sell 2,000 of whatever, because there's an entire like Arduino ecosystem that will just click, click, click on anything that's out there, which makes it look like you're getting awesome traction, but in fact you've just saturated the market
with 2,000 sales. Yeah,
right.
And on the other hand, and they're also super tolerant of things not being perfect. Like I'll flash that thing with new firmware. And whereas consumer electronics is, like when you're dealing with consumers, their expectations are entirely like, what, this doesn't work with Windows XP? And like, no, we only got to 7 operating systems and not 12.
Yeah, I read a car review in, I think it was in USA Today, that just thrashed this one car over compatibility with Windows Phone 7. And it's like,
yeah,
this is a thing that people care about that we're not aware of here in San Francisco.
Well, a small enough, vocal enough community will care about, so that it looks like to other people that your product sucks.
Right. So how do you, we think of this kind of startup that's able to grow because they have, an enthusiastic sort of Kickstarter market, Kickstarter community that's really into buying a beta product and experimenting with it. What's the inflection point where it becomes a mass market consumer product? And if can you think of any companies that have gotten past that inflection point really effectively?
So this is the project that we've been working on at Smart Design just recently. Startup here in San Francisco called Emotive. They make wearable headsets that read brainwaves, and they've had a product out for scientists and early adopters. They just did a big Kickstarter and got lots of money from a Kickstarter group. But their end goal is to make it for, and what they told us was like, we want this to be in Target. We want this to be on Oprah. We want this to be on Ellen. We want people to be able to really use this. And so the big step up is how do you start to shift away from the Kickstarter community, the developer community, without alienating them, but instead start to kind of bring them along and make it kind of a lot more user-friendly for people who are just buying things off the shelf at Target. I mean, it's a huge gap there.
Right.
So, and some of it is really just focusing. I mean, it's all user experience focused, making sure that the brand speaks to both audiences, making sure that all the little things, all the micro interactions are really polished. When you turn it on, you don't want to be having to figure out how does this thing connect to the internet? Like what if you can't connect to the internet and you can't get any of the value out of it, you're gonna just get rid of it. So just really focusing on all those little moments and not and making sure that everything is kind of seamless and works really well, because the bar has been set really high for that. So so it's really that level of polish that's really required.
Yeah.
We also see a lot more use cases for people using crowdfunding in different ways. So, for example, Misfit launched an Indiegogo campaign not as a way to get funding. We had already raised a Series A at the time that we did the Indiegogo, but to ask the question, hey, if we build another activity tracker, do people want it? because there are already a lot of activity trackers out there. So another reason to do something like Kickstarter or Indiegogo is less about the funding and more about, hey, are you actually interested? Do you want to be our beta testing community? Do you want to give us feedback? And really to turn it into something that's, instead of we're going to build this in a vacuum and then put it on shelves, to be part of this process and help tell us what you care about. And I see more companies moving towards that, where it's kind of a hybrid between you're not two people in a garage wanting to make something and sell it, which there are some great stories from that. Manufacturing is still hard. And you're not necessarily just pre-releasing your product, but I think that we're seeing more different use cases.
And how were you able to tell in the case of the Misfit Shine that the pattern you saw, the demand you saw in the crowdfunding campaign indicated real mainstream consumer demand and not, not just sort of enthusiast demand?
Sure. Well, we hit our goal, which was I think $100,000 in the first few hours, so that was a pretty good sign. And I think that the bar keeps getting set higher and higher for Indiegogo and Kickstarter. But at the time, we raised $850,000, which was a lot given what people were funding at that point. So that was for us a strong enough level of interest.
So was that so when you raised that much money? So what I've found is that the amount of money that you raise crowdfunding is basically barely enough to cover your costs in developing and manufacturing the thing, and thus it's essentially purely a marketing ploy. Did you guys find that also, or was there some profit on top of that that you could roll into your R&D or whatever?
So I can't speak to the exact numbers, but the goal for doing this was less about pre-sales and really, hey, Fitbit's out there, Jawbone up, Basis, there are Fuel Band, there are a lot of similar devices. Do people want another one? What is people's appetite for this? And I think that that's a really good use of crowdfunding, which is, I think if you're using it just for the money, then you might want to be a little bit concerned because things are probably more expensive than you think they are. And if you go to the hardware startup meetup or the sensor meetup or any of these meetups, you can hear tons of war stories about this.
So Dan and Mike, you both work with a lot of big companies who sort of come to you from outside of this immediate area and are looking for advice on software integration, on hardware, on industrial design that ties all of it together. What are they looking for from you, and what do they want from this community?
I'll let Dan speak, unless he lets me speak.
No, I want you to speak first.
So most of PARC's clients are very large, kind of Fortune 100 companies, and the ones that we work with are essentially companies that already have a lot of technology, but what they're struggling with, and a lot of it is actually deployed out in the world in what I call kind of physical networks that aren't like digital networks. So, fleets of trucks, fleets of trains, things like that. And they actually have a lot of embedded technology in them, but that technology hasn't been tied together to make sense as kind of a single system. And so one of the things that we kind of work with them on is how do you tie all those pieces together. And we were talking about this earlier. Like, the interesting thing is that I think to some extent they come in and they go like, well, we've been doing kind of embedded sensing forever. And my retort to that is usually, well, you haven't actually had it connected to the cloud. You've had it connected to a gauge in a control room down the hall. And that's a very, very different thing. It might be the same sensor, but it's a very different service. It's a very different experience to have that be part of a kind of cloud-based, analytics-based experience.
Do you think they see these new style hardware startups as competitors or collaborators or neither?
I mean, so many. We don't do a lot of work with consumer-facing stuff, and the vast majority of startups are in the consumer-facing space. I think there's a huge opportunity, a huge disruptive opportunity in kind of the industrial space for startups. But But yeah, I don't think it's really a competition. Also, frankly, I think a lot of startups haven't yet hit that inflection point where Samsung is likely to notice that they're violating 45,000 patents and are going to sue them. And so, so they haven't yet. But in the industrial space, I think that's a little bit cleaner.
Sure.
So, yeah.
Right, and most of our work is in the consumer space. So a lot of these large companies will come to us and say, "Hey, we have this thing, and we don't know why anyone would use it, or we have this thing, and we're going to put a screen on it and connect it to the internet. Why? What's valuable about that? Why would people want this? Or hey, we're pulling all this data off these things.
Are you?
Well, we would like to pull all these data off these things,
right.
and
so would we all.
And we don't know why people would even want this data, or what's valuable
right.
about this data, or what's valuable about connecting your toaster to the internet. Like, what are those things? And so there's a lot of
nothing.
That. Yeah, exactly. So, although there's that cool thing where you can print your the weather report on your toast. That's really nice.
You could disable your toaster unless you've walked enough.
Yes, exactly. It'll lock your fridge unless you've walked enough. So, so there is a lot of kind of like meaning making that people come to us for, or they'll come and say, hey, we have this new technology. We have a curved screen. What could you do with that? What are the various applications of that? How could that fit into current ecosystems? So we have a lot of those kinds of challenges coming kind of from outside.
And do a lot of these companies see the opportunities in interoperability and in like making their connected washing machines or whatever, connected toasters, part of an ecosystem where you can control it with if this then that, or through a connected home platform or something like that?
So it's interesting. So a lot of the bigger players that come to us, they're like, we're going to own the home, and we're like, no, probably not. The people who own the home already own the home. So,
well put. Tweet that. Yeah.
You are lucky if you're going to be able to get a piece of it, because all these things of technology, they're fast. They have a limited lifespan. Your house has a very long lifespan. So things and there's a big resistance to bringing in new things that have to be maintained. They have to be looked after. It has a new service. I'm not sure whether it's going to be valuable to me. So getting over that kind of value hump, is this going to be valuable to me? That's a huge thing. But people, so we always are cautioning clients like, hey, you're probably not going to own everything. Start with one thing. Focus on that. Make that as good as it can, and make it as interoperable as you can. And if you can, start pulling out pieces of data, surface data that then could be used, by other things. Maybe not now, maybe a year from now, maybe 2 years from now.
You were about to say something.
Well, I've had this conversation also. Back before I was at PARC, I was a consultant. I consulted with a lot of consumer electronics companies. They have that. A lot of them have that philosophy. But there's this fundamental disconnect that often happens. I think actually in a lot of hardware, there's kind of two fundamental disconnects, and one of which is that a lot of hardware is a solution looking for a problem. And I think there's just a ton of and essentially there's a million different ways to solve a problem in hardware if you have a problem that needs solving. And it's much more important to find that. And a lot of these companies don't. They're just like, well, we can manufacture anything, so we will stick a screen onto this. And that's kind of like I think the fundamental kind of fun. And I had another idea, but I lost it because I've been awake all day.
Yeah. I think this is, you also bring up my summary of the state of self-tracking, which is all of these things are useful right now. I call it BYOQ, like bring your own question. If you have a question that involves getting data in the form of how much you slept or step count, as a way to answer that question, you're in luck. There are so many devices to help you do that. But if you don't have a question you're trying to answer that requires data to help you, these things aren't terribly useful yet. I don't view that as a criticism of the field of wearables. I don't think wearables are going away. Whether we're going to want to get the number of steps we've taken each day and use them to answer questions about ourselves, maybe we'll do that in the future, but probably it'll be the same subgroup of people that does that now. But what these will enable is passive tracking of our activities to be able to look at longitudinal trends, and being able to correlate multiple sources of data over time is going to be really powerful in allowing us to predict things about our health. So especially for health applications, but also in terms of interactions with our environment and objects around us, and being able to better understand our behavior. I think that trend is not going away. These connected devices will be in things that we're wearing, whether we want them to or not. Whether they're going to give us a readout that tells us how many steps we've taken each day, unclear. But there's no question that the connected devices that we wear, like that trend is staying.
Yeah, and the value is going to come from like the applications and insight that happens on top of it. I'm always impressed by Google Now as an example of the kind of low friction interaction with a system, right? Where my Chromebook has my location because I have an Android phone, and notifications that it'll take 25 minutes to get to my next appointment pop up in my Google operating system, when my phone is in the other room. And it's just brilliant. I think that you can imagine that sort of thing.
The predictions that this kind of data is going to enable are what's kind of going to be the magic part of it, for sure.
Yeah. I think the magic is in the analytics. It's not in the hardware. Yeah, I think that's really like the hard. I think one of the reasons why, at some level, the barrier to entry into hardware is actually somewhat low, is because the stuff that you can do is actually not very sophisticated, and that the really interesting sophistication is actually up in the cloud. I actually remember the second thing that I wanted to say.
Go ahead.
And so it's actually about replacement cycles, and that a lot of people have experience with consumer electronics, which have very tight replacement cycles, or software, which has insanely tight replacement cycles. So software, apps update every day. Hardware, consumer hardware updates annually or a little bit less annually. And people forget that, like, you change your stove once a decade, if that. You change your car about as often. And unless you're in San Francisco, you change your house even less often. So, maybe if in San Francisco, if you're rent controlled. But anyway.
I wasn't going to bring that up.
Yes. Then you're in it until the 21 teens. But I think it's these, Stuart Brand's shearing layers keep coming back up. So if any of you haven't seen this concept that Stuart Brand did in How Buildings Learn years ago about shearing layers, about how there are different layers in a building where the site changes very slowly, and kind of the building structure changes a little bit more quickly, and then the kind of infrastructure changes a little more quicker than that, et cetera, et cetera. I think those same kinds of shearing layers exist in kind of hardware replacement cycles, and I think there's a lot of confusion about where a different product is and what people's expectations of it are.
Yeah. Well, you're starting to see people do really interesting things with the hardware replacement cycle and building functionality into hardware that anticipates future software updates. Yeah. Like the first generation of the Nest, right, that came out with some mesh networking radios that weren't used in the initial implementation of it. One of the speakers at Solid is going to be Rob Kuniavsky talking about storytelling through hardware, in the same way that a web application can sort of develop along a story over the course of the first year or something. You can now do that with hardware by anticipating where you're going, building in an abstract enough, set of layers to really work with.
But then your BOM cost goes up, and since your margins are so thin, your profit drops, and so you have this crazy set of constraints around that. Which is all. I'm sorry, I'm making hardware sound really bad. I actually love it.
It's a harsh mistress. Yeah. We touched on heavy industry a few minutes ago, and I think this is another area where that's interesting stuff is happening in heavy industry because maybe the car replacement cycle is 8 years. Like a piece of industrial machinery is like 30 years. And their jetliners flying today. A lot of FedEx's planes are like 40 years old. They were built in the 60s and early 70s. Those replacement cycles are incredible, and so you have these systems where people are doing very clever things to add intelligence onto platforms that never anticipated the kind of intelligence that you see now.
Apparently, hospital hardware is very hackable if you read the Wired article this week.
Yeah.
Which is also another example of industrial hardware that's very old.
Right. Well, and big privacy implications from all of this stuff as it's getting connected. Never anticipated the connectivity. And so you run into a lot of really interesting security holes that basically amount to like someone discovered that the username and password on some MRI machine are still like admin, and you can log into it that way. But how do you approach sort of privacy in the hardware that you produce and anticipate the challenges there?
Yeah, that's a great question. So, obviously, privacy is fundamental to everything that we as a company do, and for any wearable company, like we're collecting data about people's personal lives. It's at this point, it's not terribly interesting data, but which is a good thing because as a field, we still have a lot to figure out about policies, how much access should and this is a whole separate topic, but how much access should people get to data? How much can you share? And so as a field, we're trying to figure out what privacy means. There are obviously different regulations. If you're sharing your data with a healthcare provider, then you fall under HIPAA. There's a big set of regulations there. But I think right now we try to do everything that we can, but as a field we haven't yet necessarily come upon a common set of standard practices.
But you're working on it.
We're working on it, and we worry about it.
Yeah, I mean, at a minimum, I think that end users should know, what data is being collected and how it's going to be used. I mean, I think that's a nice metric to have. But for us doing consumer stuff, it's a lot. I mean, there's a big kind of uncanny valley when it comes to data that's being collected. Like, as soon as you start to hit that, it becomes really creepy. I don't want all the appliances in my house spying on me, oh, hey, it looks like you and your wife are getting busy, can we suggest this, thing? And it's like, I don't want that kind of, invasion.
We're going to lower the disco ball now.
So exactly, we're going to lower the disco ball, exactly, and that'll be collecting different data, yeah. But there is this definite feeling, and people generally have a good sense about where that line is, and it does vary by context. I mean, there are definitely things you don't mind. You don't mind, TiVo or Amazon knowing what movies you're watching, but there's other stuff about people knowing if you're in your house alone and stuff like that. That becomes a real security issue. And that's where it starts to get into like creepy strange land. Yeah. So it's a hard question. I mean, especially as we start putting cameras in everything because they're so cheap now.
Hardware is a much more intimate data collection than software alone. I mean, we're all used to exactly what you're typing into Facebook. It's really easy to forget what this hardware that is having direct contact with your life in all sorts of places is doing. But that's why. Glad to know that you're worried about it. Working on it.
We're also at the point where there are apps being pre-installed on our phones that we don't even know about that are collecting kinds of data that we may not want to share.
Right.
Like Google Now has a microphone that's always on. It's listening and waiting for you to say, "Okay, Google, what else is it listening to?"
Right. Yeah. My one suggestion for people who are doing this is that because. So my one suggestion is don't store any information that you don't have an immediate use for. Like that doesn't immediately answer your question. Oh, no? You disagree?
But you're getting rid of all this data that you can use in the
Right.
future for looking at rich correlations.
But-
so I would have to say that there are some kinds of data that you don't want to store, period.
Right.
But there are other kinds of data that you're not sure how you're going to use exactly. But so, for instance, like how many steps I take each day, I don't know how I'm going to use that in the future from 30-something devices. Does that mean I shouldn't store it? That's the kind of thing that's painting this really nice baseline picture for myself that over time I'm going to be able to look back and say, this is what normal looked like before this event happened. Or I can look across a population and say, for women in your age category, this is what normal looks like, and you're deviating like this. Or when some health event happens, we can look back for the past 2 years and start to see hints of that happening. But if you say we don't want to record the data unless we know how we're going to use it, you lose all of that predictive power.
Well, I agree, although I'd say that your argument, you just made a reasonable argument for storing that column of data that you just described.
I'd say that's true of almost all data, though. The more data I can collect about myself. So I hate manual tracking, but anything that I can passively record, I'm interested to look at how it looks with the rest of my data.
I mean, I personally worry about this because I was just talking to a big company that is buying up smaller companies for the data that they've collected, and then joining that data, and what they're doing the kind of thing where it makes sense for them as a business. It's a little bit scary for me as a consumer because they're buying up a company that might have sold me a ticket to something, and another company where I might have rented something, and then they're looking up my phone number in both places and unifying those records.
Sure.
And for them it makes total sense. For me, I'm like, that's a little weird.
Yeah, I mean that's a kind of collation that's been around for a while, and it's the results of it are being presented more magically now than they used to. When you see an ad for Hotels.com, to book the nights that you were just looking at, 10 minutes ago on a different website, that's a very striking thing. Axiom has been around doing this. With Walmart and Kroger data for a while, and these are sort of new ways of So we are getting to the time in the evening where we'll take audience questions. But before I do, I'd love to ask each of you what's something you've seen recently that sort of felt like magic.
All right, so we had a
thing that felt like data, magic. Sorry.
So we had a graduate student that gave a talk at our lab whose work consists of counting all the people in a house just by looking at the antennas on their Wi-Fi access point, completely in hardware that's already out there, and and it was. Pretty shocking because Wi-Fi reaches every corner of your house, and he could totally tell you how many people were in your house and where they were, roughly speaking. That was pretty magical.
Rachel or Dan?
This is a pretty low-level version of magical, but it's always interesting to look at the data from my devices and learn something about myself that either I had forgotten or I hadn't realized. So even though these things track steps, which may not be the thing that most people here care about, they also show you how active you are over the day. And it's interesting for myself to relate that to my mood. So the last couple weeks I've been busy, and I've been coming back from traveling, and I haven't really made time to exercise. And looking at my Fitbit reports at the end of the week and my Jawbone Up reports and looking at my Shine data, I've really been not active. And just seeing the relationship between how I feel and what I'm doing, even though this is very, very simple, is kind of magical. And I'll also just throw in one analogy that I like to make, which is that I like to compare all of these things to the early days of cell phone cameras, which sucked, but the best camera is the one that you have. And similarly, These are very rudimentary. They're mostly just accelerometers with a couple exceptions. But over time, they're going to get better and better, and just in the way that we don't carry around cameras with us anymore, because our cell phone cameras are good enough, these devices, the wearable devices, are going to similarly get better. And so I view these as the early, ugly cell phone cameras, but they're on their way.
And for me, the most magical thing that I saw, I had a meeting a month and a half ago with a bunch of neuroscientists, and we were all talking about connected cars and self-driving cars, and the car manufacturers and the neuroscientists are partnering to do things, to do this kind of predictive technology that is predicting what you're going to do with a lot of accuracy a second or a half second before you're actually doing it. So, and they can adjust the car based on that and adjust where you're going and stuff like that. So having that kind of and it sounds like it's almost nothing, but a second is actually a pretty long time in a car, and it can be pretty amazing, the kinds of adjustments that the car can do in that brief amount of time, and the car space is going to be amazing in like a couple of years.
Awesome. My bit of magic, by the way, is a visit to Botan Dali a few months ago, which was really extraordinary. Robotic cinematography, cameras mounted on big industrial robots and controlled through really incredible interfaces that work through like Maya plugins. So it's the most fluid integration of software and hardware that I've ever seen. I think it lets people sort of conceive virtually and then implement physically immediately, and with complete coupling between the two. So let's go to questions from the audience. We have a few minutes.
Thank you for the wonderful presentation. My question pertains to your comment about big company buying up small companies. I'm sort of a student of popular music industry. Popular music industry has gone through these cycles where a small number of very large record companies have controlled everything and controlled all the radio stations, and then these periods where there's a lot of innovation and a lot of small record companies innovating and coming up with new artists and new ideas and new sounds, and then the big companies sort of scoop it all up and take over again. I'm wondering if there's a risk of the same kind of cycle happening. Right now we're all intoxicated with innovation and venture capital and this bubble of startups and everything. I'm wondering if there's this risk that at some point larger players are going to sort of take over everything and sort of put a damper on this small startups.
Well, I mean, I think that's already happened with...
Yeah, I was going to say, you can strike the word risk out of that in that it's reality, practically.
Yeah, I mean, that's if you're in the robotics business, Google bought you. You know, unless you're kind of a handful of small, like if you're in the robotics startup business, Google bought you. Yeah, I mean, I think that's true, but I think there's also, I think there's an indie electronics scene that's very interesting, largely because of the crowdfunding angle. Because big companies, for them, an N of 1,000 is nothing and nothing worth investing. But by N of 1,000, I mean making 1,000 units of something.
Right.
It's just not worth investing. I mean, making 10,000 or 50,000 is just not worth the investment. Whereas for small startups, especially small startups that are trying to find a niche and are willing to iterate very quickly and find markets by making N of 500, N of 1,000, N of 2,000, there is a huge opportunity there. And so I think there is this great both opportunity and to some extent it's happening in the electronics scene. It's not the consumer electronics scene. It's not competing with Samsung and Vizio. It's not even competing with Nokia anymore, obviously. But it's finding these niches for specific experiences that are enabled by hardware technologies. I think most of those experiences right now are kind of in what's called the accessory market. There's a lot of accessories. It's like, oh, it's a thing that's connected to an app. But there's still a lot, I think, of innovation there. Some of those companies will get scooped up. Whether there's going to be a wholesale scooping up like there was in the robotics industry, I don't know. But I think that may be because, as you're saying, like I think the robotics industry had kind of like a 5-year leg up on the electronics industry. And so that may be like a 5-year cycle. They'd gotten big enough and the Google decided they wanted all of them. But
I see a lot of hands raised, so let's go on to the next. Go on to the next question. Yes, over here. Sorry. Yeah, Lewis will come to you with the microphone.
Hey, Lewis. So my question is similar to the question he asked, but from a different angle. Rachel, the comparison you made, kind of where we are in an industry with all the wearables, I instantly thought of something else. Several years ago, everybody was making MP3 players. Right? You had 60 MP3 players, and then one company decided to come on the scene. Where are all those other players now? So the question is, with Nike's recent announcement of kind of closing up shop and the association between Nike and Apple, what's this landscape look like over the next couple of years for everybody else?
Sure. So we know what MP3 players are for. They're for listening to music. We're still trying to figure out how to make these devices useful. And so I view it not only as a design issue and what we want to wear on our wrist and making it like the iPhone, but so that is definitely one element, make it wearable, because the things that run out of battery overnight, I'm not wearing. But I think with respect to integration with more of the clinical applications, we're not there yet, and I think that there's still a lot of opportunity. And anybody who can do something that, either from a consumer perspective, makes one of these devices indispensable. Like, oh my gosh, this allows me to do this thing that I haven't been able to do before. It measures my blood glucose continuously, which exists, but hooks it up to some kind of service like Postmates that delivers food at my door when my blood sugar drops below a certain level. Would I pay monthly for that? Probably. So these kinds of services, we don't yet know what people will pay for, but I think there's a lot of room there.
Excellent. Yes, we're here. I'm enjoying making Lewis walk back and forth.
Back and forth. Yeah.
Sorry.
So you've talked a lot about various constraints that apply to hardware and often not to software. I'm curious which of those constraints you think are going to be broken soon. Like, when you look at the walls, which of those are coming down in the next couple of years?
Battery life.
Battery,
definitely.
yeah.
Just kidding. I wish.
No, really?
I would say battery life is the Achilles heel of all of these devices. I would love for it to be the constraint that gets broken, but that's just wishful thinking.
Well, I think everyone wishes that they could that someone fixed batteries. That someone like right now, batteries are like, if you look at the curve, the battery version of Moore's Law, I can't remember what it's called. Like, batteries have really improved in the last 20 years, like 50%. And yeah, it's not.
Right. It used to be processor speed and memory, and now it's bandwidth and battery.
Well, I guess his question was like, what do you think is
going to get smashed? Yeah. I mean, I'm with you guys. I think it's, I'd love it for it to be battery.
Yeah.
I don't think it will necessarily. I hope that it will, but I'd say that I guess it's not hardware or software, but usability and trying to understand how to integrate these devices into our everyday experience more passively and in a way that doesn't have to be in your face but kind of comes up in the right context. I think that that's something that we're going to make a lot of progress on.
Yeah, the platforms are going to definitely start to solidify in the next 5 years. They have to.
But I still want the answer to be battery life.
Yeah. I mean, I see two things. I think that there's going to be a sea change, but it's going to be an incremental sea change because of processor speed. Processor speed, essentially, like you look at Arduino, you look at Raspberry Pi, you actually see kind of the progression there, and I think that that's going to continue because essentially the way that industry works, the way that that industry works is that it essentially pushes today's processor speeds to yesterday's prices tomorrow. So, if that makes any sense, I'm not actually sure. But so I think that's going to be an incremental change. I think that there's going to be an incremental change in manufacturing capabilities, which will allow allow the efficient manufacture of units of 10 to 50 of a product. Right now, it's still hard and expensive to make less than 500 of something and make like even a penny on it. I think that's going to come down, and what that will do is that will increase the cycle time enormously because people will be able to like make 10 of something or 50 of something, sell it this week, and then make a different 50 next week. And I think that's going to be a big thing. But that's not really like in the hardware itself. It's just how you make it.
Yeah, I think that interoperability is definitely going to get much better. Right now, we're at a place where most of these devices don't really speak to each other, or they speak to the app within a given silo, and people are all trying to build their own platforms. We're going to own this space. We're going to own this space. And that's got to change because none of these devices are as useful on their own as they are when integrated with the ecosystem. And that's something that's not quite happening yet. People are at least releasing APIs, which is a first step, but I think that we'll see a lot more integration, and that's also going to lead to like huge changes in the area that I'm most excited about, which is the data side, being able to actually do interesting things once we can take in multiple streams of data.
Excellent. I think we have time for one more question. Yes, you.
So I just had two things quick. I expected to hear about the Tricorder Prize, and do you guys think there's value in prizes to push hardware development? And is it going to be someone here that wins it, or is it going to be a team like a GED that pulls it off? And the second, I really expected to hear about Project Aura from Google and having modular hardware, and whether we'll all be on like a hardware app store developing modules for a phone in a year.
My comment about Project, I don't really have much of an opinion on prizes. I think maybe they're valuable. I don't have that much of an opinion. I think modular hardware has been tried several times before, and unless they're doing something really magical, I think it's an interesting exploration, and it's probably going to push some of their manufacturing methods. But my personal feeling is that it's an interesting one-off, one-year project, and Bug Labs was there first.
Yeah. With respect to the tricorder, so a little bit of background. I started a company that was in 2011 to make an open source hardware platform that was allowed people to prototype and build on it with the goal. We got really excited after seeing Chris Anderson talk about DIY drones. Like, that's awesome. We want to do that for the medical tricorder. We'll build this thing and people can prototype and build on it. They don't have to know that much about programming Arduinos. My sister's a med student. She doesn't know anything about programming. Great. That's nice, but it's not a business. And that was the problem that we ran into, which is you are now making a developer device. Great, you can sell it on SparkFun, but that's very different than building a consumer-oriented device. And so we ended up shifting away from that entirely, and it was for lack of business models. And so for prizes, I think they can be really cool, especially from within a university or other kind of organization where you don't need to necessarily make a profit. But as a startup, you need to exist next year. And if you're focusing all of your efforts on research, then that's just not going to happen.
I have nothing to add. They did it very well. They answered very well. They answered too well.
All right. Do we have time for one more question, possibly? Or? One more question.
Do we have any women who have questions?
Just behind the column there. You've had your hand raised. Yes.
Come out from behind the column. So one of the things that's really exciting to me about the hardware ecosystem is the barrier to entry has gotten significantly lower, particularly in price and the ability to build things and not have as much knowledge. However, here, particularly in San Francisco, we have a big problem of thinking about consumer products and business models and not really thinking globally. So I'm curious what your reactions are there going to be innovations that are thinking globally and building global solutions? And what innovations in hardware could that happen?
I would say that thinking globally, at least with respect to health, there are some things that are actually way more exciting going on outside of the U.S. because the regulatory framework is different. And that doesn't mean that people are building dangerous devices that are causing harm, but that it's much easier to prototype and try out devices or technologies without having the FDA in the way. And so I think that this movement is not just here. There are hacker spaces and maker fairs even all over the world, and people from our community here that are ambassadors and go out, but also people working on these things all over the world. And so it's not just a Silicon Valley, Bay Area thing. And also everybody's pushing their code and their tutorials online, which is global as well.
Yeah, I actually think that a lot of the innovations happening outside the Bay Area, Arduinos are made in Italy. Everybody in the Bay Area who makes hardware depends on Shenzhen, and Shenzhen has its own accelerators, and they have their own startups, and they have all that. And India's industrial designers are great, and so I think actually a lot of hardware innovation is actually happening outside. I do think that San Francisco has a lead on software platforms, and since so many of these products are driven by cloud-based software platforms, the Bay Area will continue to lead in that space. But the hardware, I think, innovation's actually largely happening elsewhere.
Yeah. I'd say that one other thing that the Bay Area really is amazing at that is not quite the same elsewhere is community. It's hard any night of the week to decide which events to go to, given that some nights you need to go to sleep or do work or do other things. And any given night of the week, there are hardware events, there are software events, there are digital health events, there are data events, and you can't go to all of them. But I think that what's awesome is that any one you do go to, there are lots of people working on similar things, and all of the communities that I've had the luck to be involved with, everybody's been really helpful and willing to come help you figure out how do I debug the Bluetooth stack on my Android app or whatever it is. And so that's one thing that we have here is a density of communities that I haven't seen elsewhere.
And I just have one other little thing about globalization and localization. I mean, I think that there's a lot of unique opportunities in different parts of the world to have different kinds of hardware. I mean, we send teams to Brazil, to India, all these different places, and they just have different needs. They need different things out of their refrigerators. They need different things out of their TVs. They need different things out of their appliances. And being able to think about those and customize those and create, maybe it's a different module that gets put into refrigerators in India versus refrigerators in Brazil. I think there's a huge space there, and it's just now starting to get explored.
Excellent. Thank you all so much. Thanks so much.